I've started recording. So in this, we would be showing the demo video on how do we use. So sir, could you please tell if you could see my command prompt?
Yes, I can see.
Okay, so we actually start, if somebody wants to use the BIGBOY1.2, they first clone the GitHub repository, then install all the dependencies, such as all the dependencies could be installed by pip install r requirements.txt. I'm not doing that because I've already installed all the dependencies. So we run the model by running. So actually I can't see this. Yes. So we have three modes. The three modes go by batch, interact mode, and a random mode that generates a random dataset. So first we would be doing the random mode. When I click enter, it would be generating a random dataset, and it is saved in the datasets folder. So now we would be showing the dataset folder. So actually, sir, this is the dataset we just generated. Could you see that?
Yes, that Excel file, right?
Yes, sir. So these include, this is the extended dataset. So which includes susceptible, exposed, infected, and other columns like that. Beta effective and reproduction rate is also there. And we could see seasonality is 1 because it is a random dataset. It took seasonality as there's no seasonality in this dataset. So along with the dataset, we also produce a parameters file so that it could be reproducible. If somebody wants to make the same dataset, they can paste the same parameters and get that. Then we have this file. It could be used for benchmarking. It just includes the reported cases. So we could see whether just having the reported cases help better in training models than having the bigger dataset file. And just like the random mode, we have a batch mode as well. In the batch mode, we write batch x, and x could be any integer that could generate a diverse set of datasets. I'm not generating that now because generating floats take some time, around 5 to 10 minutes. So it's a pre-generated batch we should show you here. So here we can see it is same as before, but now visual floats are also included. Visual floats such as it is the SCIR compartment float. Could you see that, sir?
Yes.
Yes. So, and we have included other things as well in that, exposed versus newly recovered, and various sort of floats that could be used to visualize as well. This is the seasonality versus infected. Mainly, most of the time, infected are mostly colliding with seasonality, but in this case, they are not. And we also generate phase diagrams as well for this dataset, phase diagrams and other sort of graphs as well. And actually now we'll be showing you that each and every dataset generated is diverse and could be reproduced. Like that could be like that. Just wait a second. So these are the epidemic simulations generated from 6 batches. All of them are different. All of them look like disease outbreaks, and all of them are tuned, and so all of them could be used for benchmarking as well. Then the third mode, and I think the most useful of them, is the interact mode. Also, you could write H to open the help. So these are all the things you could do with the model. And now we would be doing the interact mode. In the interact mode, the user could define his own populations, typing random numbers, the number of days he wants to simulate, the initially infected, the mask adherence state, the crowdedness. Suppose we are in India, I'll say it is crowded. Enable quarantine, whether I want to enable quarantine or not. Quarantine, in our simulations, quarantine would isolate 50% of the individuals. So we could enable seasonality as well. We could enable interventions such as lockdown and other things. We could have multiple waves as well in this. We could enable vaccination. We could then tell the vaccination rate required. It could tell the incubation period and number of network layers. So number of network layers is like defining how many layers does the city simulation have, like household, community, schooling, and other things like that. So we would say it has 3 layers, and we would say it has 3 age groups: children, adults, and elderly. Then we would be telling how many variants does this event have. Multiple variants would generate multiple waves, so we would say 2. Then it is asking about the day of the wave, the beta multiplier, and the new seed number exposed around the dramatic wave. So it's now so we can press enter as well, so it would take random numbers. Testing rate, we would say that the testing rate is low. Mask decay rate, and then we have enable travel between the cities. So if we do not enable travel between the cities, we would see a simulation that is dying off really quickly. So then there is reporting probability, minimum max, and random seed. Random seed is really important for reproducibility of the data. So while saving this JSON file, we could feed the same parameters and have the same kind of data. So this is generated, and we could see that. This is the file we just generated, and these are the data sets. You could see the plots are not generated because I did not prompt it to generate plots. So
but data
set is generated. We could generate plots by typing the same prompt. Then we have to write plots. We could write all of the plots and SIR for just the main plots. So actually, this was the demo to use that. So sir, could you please tell